Let's consider now the enthalpy of phase changes. So we have phase changes. We can have solid going to liquid phase, and we normally call this melting, but scientifically it's called fusion. Then we have liquid going to gas phase. We normally call this boiling, but scientifically we call it vaporization. And we can have solid going directly to the gas phase, and solid CO2, dry ice, is an example of this. And this is called sublimation. Now we can have the reverse phases. We can have gas going to liquid. This is called condensation. And we can have gas going to solid, and that's called deposition. So these are the phases, phase changes that we can have, and their various names. So let's consider now the enthalpy, or the heat, for phase changes. So say we have the enthalpy of vaporization. So this is a process. Delta H just means the heat for a process, and the process is the following reaction. So it would be delta H formation of the substance in the gas phase minus the enthalpy of formation of the substance in the liquid phase. So this would be the standard enthalpy of vaporization. So we're going from liquid to gas, so it's always product minus reactant. So vaporization is liquid going to the gas phase. So this is the enthalpy of vaporization for a substance. It's just the enthalpy of formation of the gas minus the liquid. And for water, the enthalpy of vaporization is equal to 44.0 kilojoules per mole for water at 25 degrees centigrade. So remember this superscript O, doesn't look much like an O. Superscript O just stands for 1 atmosphere pressure at a particular temperature that we pick. So it's 44 kilojoules per mole at 25 degrees centigrade. So if we have water at 25 degrees centigrade, it takes 44 kilojoules to evaporate a mole of water from that liquid at 1 atmosphere. If we raise the temperature of water to 100 degrees centigrade, to its boiling point, it still takes 40.7 kilojoules per mole to evaporate water at its boiling point. So you can see it's a little less because we have raised the temperature from 25 to 100. So the water molecules are moving faster on average at the higher temperature. So they have a little more energy, and they can have more energy to break the intermolecular attractions between the water molecules, but it's still substantial, 40.7 kilojoules per mole to break free of the liquid surface and enter the gas phase for a water molecule. So let's consider now melting water, solid going to liquid. This is called fusion. So we can have the enthalpy of fusion for water, and that's abbreviated FUS, and this is just equal to the enthalpy of formation of the liquid minus the enthalpy of formation of the solid. So we're going from solid to liquid, melting. And so for water, this is 6.02 kilojoules per mole at 0 degrees centigrade. I'll say we're going to have a condensation. So we're going from gas to liquid. So this is just the negative of the enthalpy of vaporization, because vaporization is going from liquid to gas. So if we just go from gas to liquid, that's just writing the reaction backwards, and so we just change the sign for the enthalpy of reaction. And so the enthalpy of vaporization with a negative sign is equal to the enthalpy of condensation. So remember, the enthalpy of vaporization for water is 44 kilojoules per mole at 25 degrees centigrade. So the enthalpy of condensation is equal to negative 44 kilojoules per mole. So that means if we take water in the gas phase and go to the liquid phase, then we release 44 kilojoules per mole of heat during the process. So when dew forms on the grass in the summer, then we're going from gas to liquid, water vapor to water liquid, and it releases a lot of heat into the atmosphere. And that's one reason we don't cool off in Mississippi in the summers, because we hit the dew point, and when dew starts forming, a lot of heat's released into the atmosphere, which keeps the atmosphere warm, doesn't allow us to cool off in the summer. Out west, you don't hit the dew point until you're in the 30s or 40s degrees Fahrenheit. So the air can cool before dew forms, and so they can cool off in the summer. So in the desert, it can be 110 degrees in the day, but it can be in the 40s at night, because they don't hit the dew point, because there's very little water in the air.